Hi everyone. Today we're going to be talking about fractions and simplifying fractions. But before we get into that, we first need to look at some vocabulary and find out exactly what the heck a fraction is. So, fraction notation is when we have a number written using a numerator and a denominator. So what's a numerator? A numerator is the number above the fraction bar in the fraction, and the denominator is the number below the fraction bar in a fraction. So normally when we're used to seeing fractions, we see a number like this, 3/4. So this top number 3 is going to be the numerator. We see that above the fraction bar right here. And then we have the number 4, which is below the fraction bar, and that's going to be our denominator. Couple of things we need to remember about fractions. The fraction bar also means divide. We need to make sure we're aware of this as we begin solving equations later on. Couple of other interesting facts about fractions is how we write them. So if we have 7/7, where we have a numerator that's exactly the same as a denominator, we say that that's going to be the whole number 1. If we actually take the time to divide 7 divided by 7, it really will equal 1. The next two fractions that we're going to look at are going to be a little confusing. The first thing we have is fraction notation for 0. Anytime we have a 0 in the numerator divided by any number, it could be 3, 4, 5, 12, the answer will always be 0. Even on a calculator, 0 divided by 3 will be 0. However, when we get to this 4 divided by 0, and we have a number in the numerator, that's actually something called an undefined number. We see that a little bit later on when we work through linear equations. But again, if we take the time to put that in a calculator, 4 divided by 0, we can see that it gives us an error message because we're dividing by 0. So whenever we see something divided by 0, remember, that's going to be undefined. And then when we look at our whole numbers, such as 9, most of the time we're able to see that that is a whole number. But if we want to write it in fraction notation, we have to remember all we need to do is put our fraction bar with a denominator of 1. It's still going to be equal to 9. We just need to make sure we can write it in fraction notation as well. So now let's get into simplifying fractions. The first thing we have to notice here is 3/4, 6/8, 9/12, 12/16, and 15/20 all mean 3/4. However, 3/4 is going to be the simplest form. That means it has the smallest numerator and smallest denominator. Or if we think about this, the numerator and the denominator have no other common factor other than 1. So we need to be aware that when we simplify fractions, we're constantly thinking about their common factors. So let's look. There are 3 ways we're going to be simplifying today. The first way we're going to simplify is by factors. So let's look at our first example. We have 12/18. So let's think about our factors of 12. Most of us hopefully will think of 2 times 6. And now let's think of our factors of 18. Because we want to simplify, we're going to try and think of common factors. So does 18 contain either 2 or 6? Yes, it does. We want to look for that largest common factor, which will in fact be 6. So if we multiply 3 times 6, we know that that's going to be 18. At this point, most of us see that we have this common factor of 6. So what we can do is just divide both of these numbers ultimately by 6, or cancel that 6 out, and we're left with our simplest form of this fraction, 2/3. Okay, we're going to try another one with factors, and that's going to be our example 2. So let's look at example 2. We have 8/20. All right, so now let's think of numbers that will multiply to get 8. Hopefully, we thought of 2 times 4. Now we're going to think if we have any common factors of 2 and 4 within the 20. Again, we want that largest factor, so I'm going to go ahead and think of 5 times 4. Because I have that common factor of the 4s, I'm just going to go ahead and get rid of those right now, and what's going to be left are our remaining factors, 2, and 5. Therefore, we know that 8/20 will simplify to 2/5. The next way that we're going to simplify fractions is by prime factorization. Now, this way can be kind of confusing. So the first thing we're going to need to do is look at our numerator and our denominator. The first step is that I need to make both of these factors of prime numbers. So if we look at the 90 first, what we want to do is create a factor tree. So we have to think of any two numbers that will multiply to give us 90. I'm just going to go simply and start with 9 times 10. If we think about our prime numbers, numbers that are only divisible by 1 in itself, neither 9 nor 10 is a prime number. Therefore, I'm going to keep factoring. Well, what times what will give us 9? Hopefully, we think of 3 times 3. Now, if I think of 3, what will multiply to give us 3? 1 times 3. Since we have that key 1 in there, 3 is going to be a prime number, so I'm going to circle it. Since we already know 3 is a prime number, I'm going to circle this other 3. Then we have 10. Well, we know that that's not prime, so we're going to list 2 more factors of 10. I'm going to list 5 times 2. We know that 5 is multiplied by 1 and 5, or the factors of 5 are 1 and 5, and the factors of 2 are 1 and 2, which makes both of those a prime number. Therefore, the prime factorization of 90 is 3 times 3 times 5 times 2. So I'm just going to go ahead and write that here in my numerator. I do want to clean it up a little bit, so I am going to put it in order, but it's still those same 4 numbers. The next thing I want to do is find the prime factorization of that denominator, that 84. So I'm going to do the same thing that I did. I know 84 is not a prime number, so easily I can multiply 2 times 42. My factors of 2 are 1 and 2, therefore I know 2 is a prime number, and I'm going to circle it. 42 has a couple of factors. The most common ones that I think of are 6 and 7, so I'm going to go ahead and look at 6 and 7. Well, what makes up 6? 3 times 2. So I'm going to go ahead and write that 3 times 2. My factors of 3 are 1 times 3, therefore 3 is prime. My factors of 2 are 1 times 2, so I know 2 is prime. Now I'm going to look at that 7. Well, what multiplied by what gives us 7? Only 1 times 7, which means 7 is also a prime number. Therefore, our prime factorization of 84 is 2 times 3 times 2 times 7. So I'm going to go ahead and write that in my denominator. 2 times 3 times 2 times 7. This time I didn't write it in order. It doesn't really make a difference. Now I'm going to look similarly that I did in the simplifying by factors, and I'm going to see if there's any common factors. I should notice that I have a 2 in my numerator and a 2 in my denominator, so I'm going to cancel both out. We can make those both a 1. If not, we can just cross them out. I also have a 3 in my numerator and a 3 in my denominator, so I'm going to cross both of those out and make those a 1. Now I'm going to look. There are no other common prime factors, so I'm just going to leave it like this since I can't cancel anything else out. Now what I have to do to get my simplified fraction is go ahead and multiply. 1 times 1 is 1, times 3 is 3, times 5 is 15. So in my numerator, I'm left with 15. In my denominator, I have 1 times 2 times 7, which is going to be 14. Now if we look at this, we do have our simplified fraction, 15 over 14. I know that was a little confusing. We're going to see one more example. So example 2 is 35 over 40. Oops, sorry about that. So we're going to start off the same way. First thing I need to do is find my factors of 35. 35, I know, is multiplied by 5 and 7. So 5, my factors of 5 are 1 times 5. Therefore, 5 is prime. 7, again, 1 times 7, so 7 is prime. Now I've gotten my factors of 35, oops, as not 3, 5 times 7. Sorry about that. Now we're going to do the same thing for 40. I can pick any two numbers that I'd like for 40. I'm going to go ahead and see 4 and 10. 4 is made up of 2 times 2. The only thing that will multiply to give us 2 is 1 times 2. therefore 2 is prime. I'm going to go ahead and circle that other 2 since I already know that as well. The factors of 10 are going to be 2 times 5. Lucky for me, I get another 2 and I already know it's prime. The factors of 5 are 1 and 5, therefore that's also prime. So I'm going to go ahead and list my factors. 2 times 2 times 2 times 5 underneath my 40. Whoops, got to extend that a little bit. Now if I look, the only 2 common factors we have are the 2 5s. So I'm going to cancel them out, make them both 1s, and now I can rewrite my simplified fraction. In my numerator, I have 1 times 7, which is 7. In my denominator, I have 2 times 2, which is 4, times another 2, which is 8, times 1, which will give me 7/8. I know that might have been a little confusing. Luckily for us, we have one more way to simplify fractions. The last way that we're going to see to simplify fractions is simply simplifying by divisibility. All I need to do is either think of my divisibility rules or just think of any numbers I can divide by in each of my numerator and denominator. So we're going to look at this way next. If I think about 24 and 21, is there a number that I can divide by both of them? Hopefully we get the number 3. So I'm going to divide both of these by 3. 24 divided by 3 is going to be 8. 21 divided by 3 is going to be 7. Now I'm going to look at the numbers 8 and 7. Is there any number that I can divide by both 8 and 7 aside from 1? Since there's not, I'm going to go ahead and say that this is our simplest form. Okay. Now let's look at our second example. We're going to try this the same way. I am going to go a longer route here just so we can see that we can use any number that we know is divisible. So 75 and 300. Some of us might not know what the largest number that divides by both of them is, but we're going to figure it out. If I look, I at least know 75 and 300 is divisible by 5, so I'm going to go ahead and divide them both by 5. So 75 divided by 5 is going to be 15. Whoops. And 300 divided by 5 is going to be 60. I still might not know what the largest number that will go into 15 and 60 is, but I know I can still divide both of these by 5 as well. 15 divided by 5 is 3, and 60 divided by 5 is going to be 12. At this point, since I'm working with a smaller fraction, I hopefully can see that 3 and 12 are both divisible by 3. So I'm going to divide them both by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Since I end up with a numerator and denominator that don't have anything else in common other than 1, I'm going to go ahead and say that this is my simplified fraction. Some of us, however, looked at this 75 and 300 and automatically knew that the number that I could reduce both of these by originally was 75. If we go ahead and look at that, 75 divided by 75 is 1. 300 divided by 75 is 4. So we didn't have to do all of this reducing here or all of this dividing to simplify this fraction. We could have done it all in one step. However, what we notice is regardless of what we start off by dividing by, we end up with the same simplified fraction, and that's our goal. Now, here's 7 for you to try on your own. Take a moment, pause the video, try and get these 7 answers, and when you've finished, unpause it and let's check to see if you're correct. Did you get these 7 answers? If you didn't, you can always retry. I know there were a lot of ways to simplify fractions, but as long as you find one that you're confident with, then you'll be good to go and you'll always know how to simplify fractions.